Hi everyone, this video is intended to be a review over a class activity that we did. So let's get started. So the goal of today is to look at this idea of finding the area between two curves. And so what we wanted to do was find the area between the curve that's given and the line y equals x. So y equals x, you know, is a line. It's a line that passes through the origin. It also has points on it like 1, 1, 2, 2, -1, -1, etc. So on this first one that I'm doing, that is this cubic function that I have here, you can kind of see that it goes like this. The one we did the day before is we looked at the area between that and the x-axis. Well, we're not doing that. So we're not looking at the idea of an area between the x-axis and the curve. It'll be between this curve and the line y equals x. So as I graph y equals x, it's going to look something like this. Okay? Straight, of course. It's much straighter in class. All right, and then as I follow the cubic, right, as I follow, I note that there's an intersection point here, and then this point goes above y equals x. Then there's an intersection point here, and the curve goes below y equals x, and another intersection point. So I'm going to mark the intersection points. There are 3 of them. But the area between the curves is going to be this area right here. And as you look at these 2 areas, you can kind of see, if you imagine, and if you drew them straight, that those areas are possibly the same area. Possibly the same area. So what we might do is we might integrate the one on the left, right? So we need an intersection point, which will be that number right there, and then to 0. I probably should make that a different color because that's not 0, that's just a placeholder. All right, and then I have the top curve, which is x to the third minus 4x, minus the bottom curve, which is x. Okay, and that would give me this red area right here. Now, this area that I'm going to color in blue right here, when I want to write the integral for that area, I would add it, right? And it's going to go from 0 to some number. Only this time, y equals x curve is above. So minus x to the third minus 4x dx. dx. Okay. Now, how do I find where they intersect? Well, there's 2 ways to find where they intersect. One way is to set the 2 functions equal to each other, and that's going to give me x to the third minus 5x equals 0. Factor out an x squared minus 5 equals 0. And then set each factor equal to 0. So x equals 0, that's that middle point here. We already knew that. That's the origin, right? We need these 2. Okay? And the x-coordinate is going to be negative on this side, and the x-coordinate will be positive on this side. So I set that equal to 0. I have x squared minus 5 is 0. X squared equals 5, and so x is going to be plus or minus the square root of 5. Okay? So that's going to give me negative square root of 5 and positive square root of 5. And then when I put that into my calculator, which of course negative square root of 5 is a really ugly decimal unless you put it in as negative square root of 5. The other way that you could find this is to put this function in y1, this function in y2, graph it so that you can see the intersection points, and then use the calculator, the intersection function in second trace, which is calc, to find those points. And that'll be a decimal. So don't round decimals. Write those really long decimal numbers so that it'll be more accurate. Okay, when we put this in the calculator, we ended up getting 6.25 plus 6.25. And so what we found from that was that indeed each of these areas is the same. And so the area under this curve would be equal to 12.5. All right, so let's look at this next one. Same thing. We have the line y equals x, and so I'm going to draw it in. And the first thing I notice is that it doesn't divide that area into two regions, not even ones anyway. Okay, but I still have an intersection point here and an intersection point here. This is the top, this is the bottom. And so when I go to write, what I really need though are the intersection points, because I don't have any of those. So I'm going to change colors. So I need the intersection points, but I do know that negative x squared plus 4 is the top function, and x is the bottom function, and so I'll write that way. Now, I need to find the intersection points, so I have negative x squared plus 4 equals x. I like my x squareds to be positive, so I'm going to move everything over to the right, so x squared plus x minus 4, and that doesn't factor. So I have to use the quadratic formula, right? So I have x equals negative b plus or minus the square root of b squared minus 4 times ac. So 4 times 4 is, so that would be a negative 16, negative is a positive, over 2a. Right? So those are my two intersection points. So the first one would be negative 1 plus square root of 17 over 2, and the other would be negative 1 minus square root of 17 over 2. So this one, I would probably put that in my calculator and then use the STO function. I would probably put that one in A. I would put this one in my calculator, and I would store it in D. I usually store it in D because A and D are above each other on the calculator. And then this one would be A, and this would be D. And when I go to put an answer in, I'm going to get something like 11.68213261. Okay, so I'm going to move a little faster on this one. Once again, I'm still looking at y equals x, so I put that through here. I've got one of the intersection points, I need the other. All right, so I'm going to do the integral. My top function is the parabola, so 4x minus x squared minus x dx. And I already know one of the integrals, right? One of the intersection points is 0. I'm using this one again, y equals x. When I go to find that, I'm actually going to find when you do 4x minus x squared equals x, I'm going to end up with 3x minus x squared, or I don't know why I did it that way, but x squared minus 3x equals 0, and when you factor that, you get 0 and 3. So that's 0 to 3, and 4.5 is your answer for that one. Okay. Then this one, once again, we're going to throw that on there. Now, this one adds a different constraint, because if you're looking at this, you can kind of see that this would probably, like if you had between the x-axis, the line y equals x, and my function, it might be this here. But I've added this additional constraint is that x is equal to negative 2, so I'm going to put that in there. That's a vertical line, right? And so my actual area between the two curves is going to be here, all right? So what do I know? Well, I know it's an integral. I know it's going to go from here, which is negative 2, to some number. I know that the top function is the square root of 4 minus x minus the bottom function, which is x dx. And then I need to find that integral. Okay, so I need to find that intersection point. So I've got the square root of 4 minus x equals x, square both sides. And then what you're going to find is that it looks like one of the previous ones we did, which is that negative 1 plus square root of 17 all over 2. And so that's what that turns out to be. When you move this around, you end up with the quadratic. So, and I want the positive one right? I want the positive one because it's on that side of the y-axis. Okay, so then when I put all that in my calculator, and I hope you will try it, you should get approximately 8.04022, etc. And the least number of decimal places that you can use is 3, right? Truncate or round, but the least number you can use is 3. Okay, so on the last two problems, what we did is we combined two curves together. So on this screen, you can see that you have curve A, which is the cubic one, right? And then here is curve C, which is an upside down parabola. And so I would write down these functions, right? I would write these down, and we're going to combine these in on the next screen. Okay, so I can do this easily, especially on a smart board that you can't, so I know they didn't think it was fair in class either, but here we go. So to figure this out, figure out where the area between is, I just put the two axes on here. And then following this up, I see that it intersects here, it's above to here, and then intersects, and then keeps going. So I have two intersection points, one of which is 0. So, in other words, what do you know? Well, I know it's an integral. I know it's from 0, because it's this right here. It's from 0 to some intersection point. It's the top, right, the top function, which is the upside down parabola, right? So that's going to be 4x minus x squared. And then the bottom function will be the cubic, which is x to the third minus 4x. And if I'm putting this in a calculator, I'm going to put it in just like that. I'm not going to do any simplifying, because simplifying is when you introduce errors into your problem. Okay, so we could set this equal to each other. We've got 4x minus x squared equal to x to the third minus 4x. I can move everything over. I have 0 equal to x to the third plus x squared minus 8x. I'm going to factor out an x because I know it goes through the origin, right? And that's going to give me x squared plus x minus 8. When I use the quadratic formula, right, for this part right here, I have negative b plus or minus the square root of b squared minus 4 times 8 is 32, so times 32. Over 2 times 1. So this part right here is going to be negative 1, and it's on the right side, so plus square root of 33 over 2. And when I integrate that into my calculator, you're going to get 10 something, 10.142, and then I have 89. So once again, you can use this to find the answer in your calculator. I'm showing you the analytical method as a review, but you can actually put that into your calculator and get a decimal. I think I got something like 2.3722. And I don't need the other one because it's way down here. It's not the area between. Okay, the last one that we did in class was this one, where I have b and d, and I'm putting those two together. So I have a square root function, which of course is just half a parabola, and then I have the upside down parabola, and I want to combine the curves and find the area in between. So presto changeo, here we go, I put them together. As we follow the parabola, we can see it intersects here. It's the top function, intersects here, and continues on. All right, so marking the intersection points, I know that this is going to be the area that I need. Okay, so what do I know? Well, I know it's the integral. I know that the top function is the parabola, which is negative x squared plus 4, and then it's minus the bottom function, which is the square root function, and so that's going to be minus the square root of 4 minus x. Now, You can work it out algebraically to find the intersection points. On this particular problem, it would be better to put the parabola function in y1, the square root function in y2, and graph them and get those intersection points. So I'm going to call this one A, and I'm going to call this one B, and once I've gotten to my calculator, I'm going to write down what those are. Okay, so I'm going to let you do that because you should be able to find, using your calculator, you should be able to find those two intersection points. They're ugly decimals, don't round. Don't round them. Use the long ones. And also use store, which is on the left side of your calculator near the bottom, STO. Store those values and use them in your, and you should get something very close to 3.849 as an area. All right. My suggestion is that you don't just write down the answer, that you actually do the work in the calculator for these problems, because it will make your life so much simpler when you're actually doing these problems for real. Okay? The assignment is page 442, 1 through 6. All you're doing on those 6 pictures is you are writing the integrals and finding the intersection points. You should not need a calculator to do these 6 problems. So make sure that you watch the video that goes with that assignment for tomorrow, and then everything else is in Blackboard. So I hope this helped. Watch it again if you need to, or ask questions when you come to class, and I'll see you then.